G'day. Let's have a discussion about why we differentiate. What exactly is it that we're calculating when we differentiate a function? I know we said we're calculating the gradients of the line that's, tangent to the function at a point x. So if this is the tangent line at that point x, we're calculating the gradient of this tangent line. But what does that actually mean? What's the point of calculating this thing? That's what we're going to talk about this lesson. So it turns out that differentiation is actually calculating the instantaneous rate of change. Instantaneous, I-N-S-T-A-N-T-A-N-E-O-U-S, well, that's a long word. Instantaneous rate of change of a function. And what does that mean? What does that mean? Well, at the value x, how quickly is y changing in the function? How quickly is y of x changing at each value x? And well, the best way to describe it is with a line, I think. Easiest way to start out anyway. So let's go ahead and draw a line. So this is x-axis, this is y-axis, and our line is going to be the function, say y of x equals 3x plus 2. So that's our function. Y of x equals 3x plus 2. Now we know from the last video, we can tell immediately that y prime of x is equal to 3 because the 2 vanishes and x differentiates to 1. And the 3 hangs out there. So y prime of x is equal to 3. Let's recalculate it just for the sake of things. So let's suppose this is the point x. This is the point x plus h. This is the point y of x, which is 3x plus 2. This is the point y of x plus h. And y of x plus h, let me get rid of this. Y of x plus h is, of course, 3 times x plus h plus 2. So that's 3x plus 3h plus 2. 3h plus 2. And then when we differentiate, so y prime of x, we know that y prime of x is equal to the limit as h tends to 0 of y of x plus h minus y of x divided by x plus h minus x. So I really ran out of room there, didn't I? Y prime of x, let's see if I'll probably go through the function. Y prime of x is equal to the limit as h tends to 0 of y of x plus h, 3x plus 3h plus 2 minus y of x, so minus 3x minus 2. And that's divided by x plus h minus x, or x plus h minus x is simply h. And now we notice we got some cancellations because we got 3x minus 3x, that's 0, and we got 2 minus 2, that's also 0. So this is indeed equal to the limit as h goes to 0 of 3h divided by h. Well, we're looking for the number that this thing gets closer and closer towards as h gets closer and closer to 0. And that means we don't actually care about what happens when h equals 0. And in fact, this thing isn't even defined when h equals 0. But for all non-zero h, these h's just cancel out. And so we're just left with 3. And, I mean, we already knew that 3 is the gradient of our tangent line because our tangent line, the line that just touches the point once, that's in some circle, and of course doesn't cross the line, that's equal to the line itself. So our tangent line is equal to the line itself. And the reason why we have a gradient of 3, what we just calculated is that when we increase x by h units, what we just calculated here is that y of x increases by 3h units. So when x increases by h units, y of x increases by 3h units. That's what that calculation that we just did here means. And so when x increases by 1 unit, so we let h equals 1, y increases by 3 units. So that's what we call the rate of change of y with respect to x. And for all the values along this line, the line y of x equals 3x plus 2, it's the same. When x increases by 1 unit, y increases by 3 units. So the rate of change of y with respect to x is 3. Okay, so that's all well and good when we have a line, but what about when we have, say, a parabola? And we'll do the easiest parabola, just because it's the easiest. This is the x-axis, this is the y-axis, and we're going to do y of x equals good old x squared. See if I can... failed. See if I can draw this properly. Well, that'll do. That'll have to do. Y of x equals x squared. And we can kind of notice something. As x, as x gets more and more, the steepness of the function changes. As x gets bigger and bigger, the steepness changes. So for example, down here, the tangent lines are going to look something like that. But up here, the tangent lines are going to look something like that. That's getting really, really steep, right? And that means that at each different point x, at each different point x, the function y is changing at a different pace as x changes at that point. We know from our last video that, well, and the first video even, that y prime of x is equal to 2x. We know that, and what this tells us is that for any x value, for any value of x, the gradient of the line tangent to the function is 2 times that x value. Let me draw a new diagram, because this one kind of sucks. I'll just focus on one tangent line this time. Yeah, okay, so let's let this point be our x, and then this is our tangent line. So that's x, and that's the tangent line at the point x. Now we know that the gradient of this tangent line, the rise divided by run, so rise divided by run is equal to 2x. That's all we know. So let's let the run be equal to 1. And then the rise has got to be equal to 2x, because 2x divided by 1 is 2x. And so what this is telling us is that at this particular moment, the values of y are increasing by 2x when x increases by 1. So when we have the input value little x here circled, at this particular moment, for each increase of x by 1, the function y of x increases by 2x. The y values increase by 2x. So that's what the slope of that tangent line means. It tells us the instantaneous rate of change. Instantaneous, A-N-T-A-N-E-O-U-S. Instantaneous rate of change. Rate is kind of like speed. How quickly is the function changing? How quickly is the y variable changing compared to x at this particular moment? So that's what differentiation is all about, finding the rate of change of the function y of x for each input value x. That's what we're calculating. Let's do one last example. And the example we're going to do is the constant function. We already know that that differentiates to 0. Let's make sure it lines up with what I've just been saying this whole time. So x, y, and let's take the constant function y of x is equal to 2. So this is y of x equals 2. And we know that y prime of x is equal to 0. Does that make sense? Does that make sense? Well, yes, it does. Because if I take any point x, and if I increase it by 1 unit, x plus 1, how much has my function y of x changed by? Well, y of x hasn't changed. No change. No change. So in fact, the rate of change at all values of x has to be 0, because y doesn't change when x increases by 1, no matter where x is. Could have been down here. This could be another x, call it x1, and then this is x1 plus 1. It still doesn't change. The y function doesn't change when we increase x by 1, and that's why y prime of x is equal to 0, because the function y is not changing. In fact, this is literally the line y equals 2, and that means y stays at 2, doesn't change at all. And so when we differentiate it, we should get 0. Okay, I think that's all I have to say about that. Thanks very much for watching. Take care. Bye.